This video is about the principle of transmission electron microscopy, and I want you to remember this tiny little thing called diffraction that limits the resolution of a microscope to half the wavelength of the light that is used for illumination. For visible light, that is 200 nanometers, and if we stick with visible light, we can't really do anything about it. We can't get below that resolution. But as always, if we are open to new things, then we find a solution. And in this case, the solution are electrons. Yes, you heard right. Instead of visible light, we simply illuminate our sample with electrons. Now, some of you might say, wait, an electron is a particle and not a wave? How is that supposed to work? And well, you are only partly right. Because electrons are kind of both. If they need to be a particle, then they behave like a particle. But if we need them as a wave, then they can behave as that as well. And you can actually calculate the wavelength of electrons with the de Broglie equation. Do me a favor and calculate the wavelength of an electron for 200 kiloelectron volts, which is typical for a TEM. Do you think we are still limited to diffraction? And that is how simple a transmission electron microscope is. You take an optical microscope, remove the visible light, add electrons as light source. You also need some expensive lenses and other expensive parts to make it work, but for the beginning, that's it. So simple. And that's a transmission electron microscope. Thanks for watching this video and see you in the next one.